everyone. So in today's class, our agenda would be to go with the Android development. We would be discussing the basic principles which are involved in the Android development and quite in depth of Android today, like the reason why Android is Android, what makes Android one of the most popular platforms, and etc. etc. So like before we start, a simple question to each one of you: what is Android? Android is an open source mobile platform which consists of middleware, operating system, and key application. Now, this definition looks quite soothing, but it is not very clear. So let's break down this definition into small jargon words. So what do you understand by the term open source? And open source is a free, not just a free project, but it is also something like in which you can collaborate freely. But I guess like I'm not very sure with the release part because you cannot the release part is not completely in your hand. Next we talk about so Android is an open source mobile platform which consists of middleware, operating system, and key applications. I hope now if anyone asks you about Android, you would be defining Android in the same way we discussed today, because Android is not just an operating system. If you're thinking that it's just an operating system, then you're actually underrating it. And if you're thinking that Android is a platform on which you can run applications, and again, you're underrating it. But if you combine all the three things, then it's the best thing to describe the Android. So an Android is an open source mobile platform which consists of middleware, operating system, and key applications. Now we would be looking these three things in detail. What exactly middleware is, what is operating system, what is key applications. Now we should be discussing the Android architecture. So before we start with the Android architecture, I would just ask again the same thing which I asked previously. So like we just said, like Android is made of three things, right? In our previous definition. So let's start with operating system then. So the very first thing which we shall be discussing is the operating system part. At the core of Android, like right now what I'm doing, I'm actually sketching the architecture of Android. So the basic thing, as I define Android, like it is collection of three things: operating system, middleware, and key applications. So I'm starting with the operating system, that is the base layer. And I'm saying that in operating system, I'm having the Linux kernel. We have the core of an operating system, that is the heart of operating system, that is known as kernel. And then we have shells. Now what shells do? Shells are similar to the command prompt, where you actually type in the commands and the commands get interpreted or compiled for us. Like every command has some program associated with it. So shells are the place where the commands get the actual meaning of the commands is conveyed to the kernel, and kernel is the component which actually takes the action. So in Android, the base operating system is the Linux kernel. So at the heart of Android, we have an Linux operating system only. So now we shall just move to the first layer. Now this is the layer where we have key applications. And so what are the key applications in Android? Okay, I'll name few, then you'll get the thing. Browser, contacts app. These are the applications which come pre-installed in your mobile phone. Google Maps, camera. I'm just talking about the generalized application, like the basic application which needs to be given to a user so that user can actually use the resources. For example, if a mobile phone comes with a camera, then he needs to have a camera app, which needs to be pre-installed. So contacts, camera, then a dialer should also be there. Then something to manage GPS should also be there. So the set of tools which are used for making an application in Java, that set of tools is called as SDK, Software Development Kit. And since we are talking about Java, so that is JDK, Java Development Kit. Then we have C, C++. So earlier in previous versions of Android, like prior to Android 4, we were also having a support of C, C++. So the kit which is used for actually coding in C, C++, like you must have seen that after completing the Android Studio, Android Studio was actually downloading something called SDK. Remember guys? It was downloading SDK because like all the code which you would be doing, that would be in terms of Java or Kotlin. But when it comes to C, C++, in earlier versions of Android, you had a provision to download another kit which is called as NDK. So NDK stands for Native Development Kit. So right now, just let's just keep Java only in the picture. Okay, so now we have Java. It's quite often that you would also be having Java libraries. After this core Java libraries, you're having some specific functionalities. Including such libraries, we have provision in Java. What we can do is like we can type on Google the specific library's name, and then we can actually download the jar for it and we can add to our project. Collection of some libraries in Java. These libraries are called native libraries. So what happened in native libraries, you're having plenty of libraries which perform different functions, and using core libraries of Java, you can interact with these. So till now in our picture of Android architecture, we got operating system, which is very clear. Then we got key applications which were developed in Java. Since they were developed in Java, we need to have some core Java libraries. And since we are having core Java libraries, they are not able to fulfill all the functionalities. Thus, we need to have some other libraries also, such as native libraries. So Android has something called application framework. Now, what is application framework? Application framework consists of some libraries which are predefined, such as Wi-Fi manager. Then there's a library called location manager. So at base, we are having the operating system, which is responsible for resource management, memory management, file management, and power and driver management. Then we discussed about the key applications, which were programmed in Java. Since they were programmed in Java, we had to include core Java libraries. Core Java libraries also need native libraries. After that, application framework consists of wide number of classes such as Wi-Fi manager, location manager. So though in Android, there is 1000 lines of code, but the basic funda is that you are not writing that 1000 lines of code. You're just writing a single line of code, and even you don't even have to write that code also. The Hello World program is already made in Android. The basic USP of Android is there is 1000 lines of code, but you are not even writing a single line of code. All the code is automatically generated in Android. That is the reason Android is so popular compared to other frameworks. So Android has application framework which provides you large number of libraries such as Wi-Fi manager, location manager, and many more. So using these libraries, if you want to make an application which uses the power of Wi-Fi, so what you can do is you can straight up use the Wi-Fi manager, and there's just a single line of code, and just using that single line of code in your application, you can actually create a Wi-Fi. You can create a Wi-Fi support in your application. You can share stuff with other people. You won't even imagine how powerful the application framework of Android is. So Android runtime over here, there's a thing which is written over here, Dalvik VM. What is VM? It stands for virtual machine. Android actually has two virtual machines to it. That is JVM as well as Dalvik virtual machine. So to understand this in a better way, I'll take you to the next slide. What does DVM does over here? Actually, Java code is not just compiled, but it is also interpreted. And you would be amazed to know that this is the reason which makes Java one of the most popular platform independent and yet a faster language. Because Java code is not just compiled, but it is also interpreted. If you all know the thing, then Java has two things inside it. One is called JVM, which converts the Java code to bytecode. And after that, there is another thing which is called as JIT. Can anyone tell me the full form of JIT? JIT stands for just-in-time compiler. So inside JIT, there is an interpreter which actually interprets the code which was generated previously. So in this way, Java code is not just compiled, but it is also interpreted. Actually, there's a problem with compilation. Whenever we talk about compilation does create the code in a better way. But we do need interpreters for managing speeds and platform independency. Java virtual machine was one of the best things which the engineers at that time made. So then why do we need another thing called Dalvik virtual machine? Why do we need this Dalvik virtual machine? Can't Java virtual machine fulfill all our needs? So let's see the answer to this question. So here the definition of Dalvik virtual machine is given. Dalvik virtual machine is an Android virtual machine optimized for mobile devices. It optimizes the virtual machine for memory, battery life, and performance. So now you can actually get the idea what is the main person who is responsible for your memory optimizations and battery stuff. Got the point? So now again the question is same. Why do we need this Dalvik virtual machine? So as you can see, the java.java file. If you remember, you must have made the Hello World program. There was a file over there which is known as mainActivity.java. So that obviously, we also studied in the Android architecture, that the first thing which needs to be made is Java source code needs to be compiled by Java compiler, that is Java C. So Java C is a Java compiler over here. So the very first thing which we do while we run the Java files while we compile Java files is Java C and name of the Java file. And then a bytecode is made, which is launched by just the Java interpreter. There are actually two things, no? There's Java C, and then there is Java. This is the compilation part, and this is the interpretation part. Most important thing, Java virtual machine is always platform dependent, whereas the bytecode generated by Java virtual machine is platform independent. So this was all fine. This is something which was happening in my Java case, Java scenario also. Now what is DEX compiler over here? Now the bytecode. If I talk about bytecode is literally a very, very heavy code. And in mobile devices, we have some restraint. We have memory constraints. We don't have that much amount of memory or RAM. We have 1 GB or 2 GB, like we have 2 GB to 4 GB of limited memory as in RAM in our phones. So when it comes to phone, you don't have that immense hardware supply. So the basic problem to handle, now just imagine if every application will have around 10 to 15 Java files, and each Java file will generate 10 to 15 bytecode files. And just imagine the complexity. Do you think like 2 GB RAM would be sufficient enough to handle all the applications at just one time? It won't be possible. So what happens? This DEX compiler actually takes the bytecode and it shortens it. It reduces, it compresses it, and compresses into a lesser amount or a file which is in a lesser size, which is also known as .dex file. DEX stands for Dalvik executable file. This DEX file is further submitted to something called packaging AAPT. Now, why do you need packaging? Your application, whenever you're making an Android application, it won't be just Java code. It would be like you will be also using images sometimes. You'll also be having sounds. You'll also be having animations. You'll be also having videos with it. So apart from Java code is okay, converted, compressed into .dex file. But packaging AAPT actually compiles the Java .dex file with other assets like images, videos, and other stuff which you're also adding in your application. And after the packaging of AAPT is completed, the final file gets to us is known as .apk file. And in Android runtime, we have DVM, and inside DVM, we'll be having the Java virtual machine. You cannot actually frame it as that way that JVM is there inside DVM. But the work which is done by JVM is done inside DVM, which is then further submitted to DEX compiler, which converts it into .dex file. So guys, like today we are stopping at this point only. From tomorrow onwards, we will starting with the major programming segment of Android. Bye bye guys.